All right, for this morning, we will be going over technical session number 4. Bear in mind, as we go through this, we won't be doing these all in order. Sometimes we will jump around. You'll see us jump to technical session 30, back to 20, back to 15. We do jump around because we're trying to marry up this material with Coursera so that the material you're getting is similar and following the same path. So we try to keep that in mind as we progress through it. Today, we're going to continue our hardware journey. Yesterday, we did a brief overview through the tour or so through the inside of the computer. Today, we're going to be focusing in a little bit more on one of those components, the motherboard itself. Our objectives for today is to explain essentially the main purpose or role of the motherboard, how it fits into the overall architecture, describe and identify key components that are found on there, as well as the interfaces. You'll get to have a better understanding of the overall geography of the motherboard and be able to point out these basic components. We touched on this very lightly yesterday. We're going to get a lot more specific today and give you a better view on it. You're going to be able to identify required maintenance checks on the motherboards as you're doing them. You're going to be able to talk about naming the steps to installing a motherboard, as well as removing it, interacting with the BIOS, knowing exactly what that is, common pitfalls you run into when you're installing motherboards and things like that, and common problems that come up with motherboards, including overheating and power issues. And then we will briefly talk about how to solve some of the most common problems you will come across. Key behavior skills and mindsets we want to keep into account when we are working, especially in the IT field. Adaptability is a big one because as the information is changing that we're receiving, we need to adapt our approach to this problem, because key pieces of information, if left out, will lead us down a wrong pathway to try to correct the underlying issue. And the main thing we want to do as techs is solve the underlying problem, not treat the symptoms that are occurring. And in the problem-solving space, persistence is key. You want to keep pursuing that answer, keep pursuing the solution to be able to help the client as much as possible. And one thing I often recommend, especially if you're working on an IT team, is even if you get to a point where you are unable to solve this problem and you have to hand it off to a higher tier or to a supervisor or something of that nature, go back later and find out what it took to solve that problem, so that the next time, if that problem occurs, you're able to solve it. And again, that becomes another tool in your toolbox, making you more valuable as an IT professional. So, basic terms. What is a motherboard? Sometimes it's being stated that it's also known as a MOBO. I have never myself heard it put this way until I actually came to Generation. I always heard it just specifically called as a motherboard. And I did know, or do know, some people heavily in the IT field, and I've never heard them use this term when speaking of it, but apparently it is a common term used for referring to motherboards. And it is essentially the foundation. You could call it like the nervous system or the backbone or the spine, whatever, the basic foundation for the computer, and allowing connection and communication and power to flow to all the attached components to that machine. It is a multi-layered circuit board utilizing copper paths called traces. Some can carry signals, some can carry voltage or power, some carry both. Some layers carry data in and out. Others specifically just supply power to the components they need. The interface to configure the motherboard and let it know how to talk to all these fun things that are being hooked up to it is called the BIOS. Although currently the BIOS is being replaced, to a newer, more updated system called the UEFI. We will also touch on that as well, and as how to quickly identify which one you're actually working on. All right. Motherboard form factors. People hear the term form factor and they're like, oh my gosh, what the heck does that mean? Well, it's pretty much just a fancy way of saying shape and size. So whenever you hear form factor, it basically just means the shape and size of whatever component you're using. They just typically use the term form factor, not just for motherboards, but for all other components as well. It applies to the case, motherboard, power supply, all other aspects that you would hook up to the computer itself. There are three basic popular, like the most popular form factors for computers or in general is the ATX, which is the largest, or one of the largest, actually is one that is a little bit larger, but the ATX, and then that is predominantly used in desktops. Then you have the Micro Atx, which also prominently used in desktops as well. And then you have ITX, which is actually considered a family of little form factors that get into mobile devices and stuff all the way down to mobile phones. So you have the mini, the nano, the pico, and the mobile. So that can go from like, you know, laptops to tablets, PDAs down to actual cell phones as well. Questions so far? We'll have pictures of the different form factors here in a moment. All right. Did everybody get the Nearpod? I posted it a little earlier. Thumbs up.
It's in Slack too.
Beautiful. All right. Yes, Janina.
As they're creating new things for computers, you said that the ones that are used like for tablets and cell phones and things like that, would computers eventually use those smaller ones?
Well, see, here's the thing. With the larger ones, you're allowed to, you have the ability to upgrade, adapt, and modify them more than you do the smaller ones like that's in the mobile phone. So you have a lot more latitude and flexibility with some of these larger ones because you'll have 5+ expansion card slots that you can use. Excuse me, you're able to install more RAM and various things like that. So they allow for a lot more flexibility when you get down to cell phones and stuff like that. Basically what you get originally is what you have, because everything is incorporated into the board and the chips are soldered to the boards. I think your only capability at that point is swapping out a battery. So in some instances, I would say yes, because right now, the vast majority of computing can be done on a tablet with a Bluetooth keyboard. Like the vast majority of the stuff that I do is done on a tablet with a Bluetooth keyboard. And then only when I need to do heavy lifting with a computer will I absolutely go to a desktop. And a lot of people don't necessarily need to do that. You used to need to do that if you're going to use word processors or spreadsheets and stuff like that. But now the tablets are becoming powerful enough to handle that kind of stuff. So, you know, I would say in some instances, yes. But for like gamers and people who are dealing with like 3D animation, you know, engineers using CAD programs and stuff like that that need a lot of heavy duty computing power, they're still going to be drawn to these ATXs because it allows for you to upgrade these systems and make them much more powerful so that you can, you know, still find functionality out of them for a longer period of time rather than having to replace them every 6-8 months a year.
It's also cheaper overall, long term, because instead of buying a new computer or device every 3 years, you're upgrading your RAM or you're upgrading your CPU or your GPU. You're only upgrading specific parts instead of buying a whole new system. And so that becomes cheaper over time. So it has a larger upfront cost most of the time if you're getting a beefier system, but it, along with that upgrade ability, it's cheaper.
You're kind of future-proofing yourself to a degree.
Right. Good question, Janina.
Yeah, I like that one. Any other questions?
I posted 2 PNGs in chat. The first one is the computer in which that those form factors could represent. The second one that just popped up is the actual picture of the motherboards themselves. So like I said, just keep a lookout in chat because I'll be sending some good pictures through that you can put in a folder and hold on to.
Thank you. All right, so here's a picture of the first 3 major sizes. You have the standard ATX, which is 12 inches by 9.6 inches. That is a very popular form factor for gamers and stuff like that because of its ability to expand, as well as other industries that rely on very heavy computing, like gaming, animation, stuff like that. Do you need to know the sizes on this? I would say to a degree. Yes.
I got a question on form factors during my A+. So yes, you should know them because
Yeah.
that's a free point.
But the easy way to kind of remember it for the most part is if you see a rectangular measurement, it's your ATX. So if it is rectangular, 12 by 9.6, then that is your ATX. If it is square, then you're into your micros and below. So a rectangular one will be your ATX. Also, if you're just looking at it at a quick glance, if you see 5 expansion slots plus right here, you see 5 plus expansion slots, good bet that's an ATX. This one has more than that. I didn't capture the AGP as well. So standard, the micro, this form factor also can fit in the same computers that use the standard ATX. The screw hole, like the patterns, the bolt patterns on it will allow a micro ATX to fit into where a standard ATX case. That's just the way they designed it, makes it a little bit easier. So know that as well. And then the minis and nano pinko ITXs, stuff like that. No, those won't. They have their own systems that they will operate in. Questions so far?
And I would just like to add, going back to what Kelly said with how the micro ATX will fit into a regular ATX, like a standard ATX tower. If you put this micro ATX on top of the standard ATX, all of these little holes are going to line up.
The screw hole patterns that you would bolt it down with.
Yeah, so all those screws line up with each other. So even though the motherboard looks differently, the places where you would connect it into the tower are the same. So that's how they kind of fit.
And from the most part, that is a standard orientation.
Right.
Because people want their motherboards to be used as much as possible, so they're going to make them compatible with as many cases as possible. It's very rare that you will come to a case that has a very specific motherboard that it will allow only. All right. Yes, Evan.
So you're saying the ATXs are all compatible within each other?
What I'm saying is the standard ATX and the micro ATX, like a micro ATX will fit in a standard ATX case, no problem.
Okay.
Now, if you buy a case that is specific for a micro ATX, you cannot put an ATX in there because it'll be too big.
Okay.
So it's a one-way compatibility. So, you know, some companies like may not want to buy new cases and stuff like that, or new towers. So they'll buy just micro ATXs because they're less expensive and go ahead and throw those in those ATX cases and it's no problem. If you're just doing standard computing like spreadsheets, word processors, PowerPoint, stuff like that, you could easily get away with a micro ATX and it would be no issue, and it gives you a cost savings in that place. All right. So the motherboard itself will determine, for the most part, your selection of motherboard will determine what type of case you can use. Again, like we were just saying, you cannot put an ATX in a micro ATX case, but you can go the other way. You can put a micro into an ATX. It determines what kind of power supply you can use, what needs it has. That's part of that determination. It also is going to determine what other components you can add, how much RAM you can add. The number of expansion slots you will have will be determined by your motherboard. What type of CPU you can use. Is it Intel? Is it AMD? And what version of these processors can you use? The motherboard determines this. Number of memory modules or RAM you can actually add can vary pretty drastically depending on the type of motherboard you use. The speed and memory, the speed of memory and CPU. The chipsets, and by chipsets, we're talking about like the North Bridge and the South Bridge, how that is incorporated. The speed at which those can transmit and communicate with the CPU, that is all determined by the motherboard. And like we were saying yesterday, your computer will only operate as fast as its slowest component. So wherever that bottleneck is, whatever's creating it, if it can only operate at 500 megabits per second and everything else is trying to operate at 1 gigabit per second, they're not going to be able to do it. They're going to have to be dragged down to that 500 gigabits per second because of that bottleneck. So the motherboard is going to determine this to a large degree. Also, the compatibility for plug and play, because the BIOS or UEFI is integrated into the motherboard. So its ability to communicate with different peripherals is determined by the motherboard itself. Questions so far? Yes, Janina.
So when you say by speed, you mean like if you put one that was 4 and one that was 8, it would go by the speed of the 4 and not the 8? Is that what you mean?
Well, what I'm saying is if your bus speed on your motherboard is 500 megabits per second, but you have a processor that could run at 1000 gigabits per second or a gig, and you have RAM modules that can process that as well, the communication cannot happen that fast because the bus speed that is allowing that transmission between those two items is much slower. So any other questions, Alan?
When I was watching one of the videos last night, it said, well, the guy, he talked about how like the different CPUs, they don't communicate. There's multiple CPUs in the computer, and one of them kind of designates like anything that you add on extra to the computer, and one of them pretty much runs like the main stuff. Would you typically have 2 different motherboards for those 2 different sections that they do, or is that?
Well, you wouldn't typically have multiple CPUs because you have the central processing unit. There are cases, I guess, where you could do that, but the overwhelming majority of the time you don't. What they may have been talking about is the other processing units that help in that communication, like the North Bridge and the South Bridge, which helps communicate with other components, and they communicate at different speeds.
Okay, because I was just a little confused because you said the motherboard. Well, I guess they kind of do the same thing then. Never mind.
No problem. That's what we're here for. We're trying to help clear it up. So if I had, I wanted to build the latest and greatest, the most powerful computer I could find, what kind of motherboard would I want to incorporate in that? Generally speaking, what form factor would I use?
ATX.
ATX, I like it. What shape is the ATX?
Rectangle,
Anybody
Well,
remember the dimensions?
12.6 in times 9, I think.
Pretty close.
12.6.
12 by 9.6.
Oh.
Very close. 12 by 9.6. Slightly larger than a piece of paper. What shape is a micro ATX?
Where
Anybody remember the dimensions on that?
9.6 by
Times
9.6.
9.6.
And you notice that matches up with one of your dimensions on the ATX, right?
Right.
So that is why those screw holes can actually match up. They are essentially on one dimension, they are the same. And then on the other, they're not. So excellent. All right. Expansion slots and sockets. First, the CPU socket. You know, your motherboard is going to determine which kind of CPU you can use. Anybody out there want to take a stab? You had a 50-50 shot. Who's the manufacturer of that chip?
AMD.
Intel.
So we got one for each team. Who wants to vote on the other one?
Intel, my bad.
Intel. Why? How do you know?
I'm just kind of looking at the structure of the CPU.
Yeah, that'll lead you there. But there's one real.
Is it by color?
Nope, it's not by color.
I think
No.
Intel are the one by like the design, like someone said, because Intel's flip up when you use the when you're trying to get access to the CPU.
Mm-hmm. Well, they
No?
do, but I'm saying if I didn't have it next to the socket, if I just showed you the chip, the underside of that chip, you should be able to tell me either way. You will be able to tell me after we do the CPU one, but just looking at the bottom side of it should be able to tell you who was the manufacturer of it.
Was
Yeah.
the middle piece of the other one like they didn't have the design on the inside of that square?
Or is it that older model?
Look at what Mark is saying. Mark is
on the
right
back.
there.
Mark, what do you say? The AMD is smooth on the back.
Smooth on the back.
He's got it reversed.
Oh, it's smooth on the front.
No.
Oh, okay.
Intel is smooth on the back.
Oh,
So Intel on the back of the chip is smooth. It is what's called an LGA or land grid array. AMD has a bunch of little pins that stick out of the bottom of it. Remember me telling you that story about, you know, the TA going to put it in and dropped the chip and it hit and it bent all the pins on the chip. That was an AMD chip because it has the pins sticking out below it. So if you're looking at the bottom of a chip, if it's smooth, you know it's Intel. If it's got pins sticking out of it, you know it's AMD. But we'll get into that more in CPUs. I just wanted to see if anybody out there was a little bit ahead on that one, but there was a lot of you were right in that ballpark. I like where it was going. All right, next, RAM modules. Down here. Your RAM banks, this particular one has them all the same color. For the most part, they will be different colors because it'll help you quickly identify the banks, how they're set up. And why would they be different colors? I mean, because of the channels they would use typically. And they're easily identifiable by these locking clips that you see on the side here. This particular one is single channel. And I know this because it's not an even number. There's only 3 RAM slots. So they're not going to operate in pairs. All right. Any questions so far on that? We'll be doing a little bit more.
I do have a question.
Okay.
If they were, like, say if it was 4 instead of 3, that would automatically make them double. Could they still be single channel and it be an even number of, like the modules?
Well, let's say for the first chip that's installed on some older PCs, yes, the first chip could run single channel. Beyond that, it would be dual channel. So, but more often today, you see them running in dual channel. Yes, Mark.
Yeah, I think I was about to ask the same question with 3 single slots there, you would not be able to run it double even if you use the first one and the third one?
I do not believe you can. I am open to be proven wrong in that particular one, but I do not believe you can. I think it is single channel at that point. Because that would be a significantly older motherboard. This would not be a modern motherboard with only 3 channels.
And the slots will typically be color coordinated. So you'll know which ones work together. And that also indicates that these two are dual channeled.
So let's say this was dual channel. And I'm digging through my supplies and I got a 4 gig and a 6 gig RAM module. Could I use those?
No,
Why not?
because they got to be the same gig.
They got to match. They got to match if they're going to work together, right?
Well, the other one slows down, right?
If it works at all.
Got you.
If you're lucky, it slows down. So yeah, you need to match up your RAM modules. The question will get a little bit complicated later because we talk about different architectures with chips, and some chips can only recognize so much RAM. So if you put more than that in there, the system will say, yeah, we see it, but it only really recognizes so much of it. So you could sit there and keep adding RAM to it all day long, but it's just not going to be able to use it. But we will get into that a little bit later in the course. All right. This was one we touched on briefly yesterday with the general expansion slot, the PCI, or peripheral component interconnect. Originally, this one had a 32-bit data path, and it required 5 volts of power to operate. But that was more than sufficient to run like NIC cards, sound cards, things of that nature that operated quite well. Version 2 doubled up on that, got you about 64-bit and utilized less power, which is a wonderful thing. Allowed for more powerful expansion components to be added to the systems. Now, because the cards can be damaged if they're inserted into the wrong slots, and this also goes for RAM and things like that, because they will be receiving the wrong voltage required to run them. The manufacturers did a wonderful thing. They basically included notches in the designs of these cards and like RAM modules and things like that, so that you cannot physically install a Gen 1 PCI component into a Gen 2 slot, and vice versa, because the slot won't match up and the component will just kind of rock back and forth. It won't go down into the unit, which is something else you need to kind of take into account when you're trying to install various components. If it does not go in easy, stop and double check your work to make sure you're not trying to force a component into a slot that is not meant to go into, because you can damage both in that process. The PCIs are kind of a legacy technology. They're not really trying to build those up anymore. With the advent of the PCIe, almost the entire industry is shifting over to that, and typically only legacy components will be used in the PCIs as of late. All right, here's kind of a look at the PCIs. They can kind of show you based on the generations. You can see they've moved the slot in either one of these, and then here and here. If you try to insert them, even if you had them reversed, it wouldn't match up very well because these are slightly off center. Also on most motherboards that still have the PCI connector for the expansion slots, it tends to be either white or a cream color. Very rarely, you may see them as very light gray though. Any questions so far? Yes, Humberto. You are on mute, sir.
Oh yeah, my question is that the PCI has the NIC card, right?
They can, yes, but you can still run you can also do a PCI on or a NIC card on a PCIe. I'm speaking traditionally speaking, they would be used in the PCI.
Gotcha. And what another question is like the bandwidth speed.
Mhm.
Does that like affect the computer's like downloading speed performance, something like that?
Downloading from the internet? No, not necessarily. You're talking about how, I mean, it affects the speed at which that expansion card can communicate with the CPU.
Mm.
So historically speaking, your ability to download from the internet was much slower than the actual bus speed inside your computer. So the bottleneck wasn't necessarily your network card. Now, more recently, if you were trying to operate like a 486, on a modern network, yeah, your NIC card would probably be the thing that's slowing you down. But typically speaking, going back, the communication between the network card and the CPU is significantly faster than the connection from your internet provider to you. Does that answer your question, Luis?
Yeah, pretty much.
Okay. Go ahead, Humberto.
Yes. What is the need to have two voltages, 5 voltage and 3.3 voltages for the slots?
Well, first, who wants to tell me how many voltages are inside the computer?
There are 5.
5. What are they? Go ahead and throw them in chat if we got them.
3.3 plus
3.3.
minus 5
Plus or minus
minus
5.
12.
Plus or minus 12. So various components have a need to operate, like how much voltage they need to be able to operate. So it is their power requirements. As we progress in technology, one of the beautiful things that happened as we talked about Moore's law a little while ago, the speed doubles, the power requirements start to go down, as well as the cost go down. So if we can utilize less voltage to run a NIC card or a sound card or something like that, if we could utilize less voltage, that frees up voltage that we can use for something else. So we definitely want to try to move towards components with lower voltages to allow us to get as much efficiency out of our power supplies as possible. So in this particular case, the older PCI slots required more juice than the newer ones. All right, any other questions? Excellent. Okay. Continuation, expansion slots and sockets. You had the Pcie X, which is the extended. It was a high-speed alternative for the PCI, allowed for 64-bit transmissions. And it was typically utilized within the server market. You had the mini PCI, which was utilized in laptops and allowed for us to kind of incorporate more technology within the smaller platforms. And it required a much lower power consumption. As almost anything that's going into a laptop, it needs to not consume a lot of power, which would produce a lot of heat. It needs to be smaller in form factor and be able to kind of work within the existing technology that is all in place. So just kind of continuing on, we spoke about this a little bit yesterday, the accelerated graphics port which or AGP for short, is typically brown on your motherboards. Though sometimes if you're looking at a picture, especially black and white, it may appear to be black. This allowed for us to start upgrading the video cards and things like that to allow for greater processing within the systems. It ended up being a short-lived bridging technology between the PCI and the PCIe. But this one, unlike the PCIs, which were connected to the South Bridge, which we will get into that here in a little bit, these were connected to the North Bridge, which is a much faster connection. And so it allowed for more realistic graphics and things of that nature. And again, you can see with the multi-generation and versions, they continue with moving this little slot here so that you are not able to put the wrong type of card or wrong generation of card into the wrong slot. Questions so far? All right. I know we've been pushing a little bit here. Can we want to go ahead and take a quick little break? There we go. So any questions real quick on expansion slots or on the AGP or accelerated graphics ports? All right. Now, continuing on it, we get to the PCIe, which is the Peripheral Component Interconnect Express. And as we talked about earlier, Express just means it goes fast, much faster. It is a high-speed alternative to the PCI and the AGP. AGP, like we said, was kind of a bridging technology between PCI and PCIe. Once PCIe came around, AGP started becoming kind of a legacy technology, but it is still used to a degree today. Just usually it's when you run out of expansion slots for PCIe, you would then utilize the AGP slot. Comes in 4 different slot sizes. Easy to kind of point out because of how big they are, but we will show you that as well in a little bit. You can get by 1, by 4, by 8, and by 16. We were kind of showing you that yesterday when we were doing the overall tour through the computer. We'll also show you again today on another motherboard. Most common is the by 16. Down here can give you kind of throughput speeds and things of that nature. No, you do not need to memorize this chart. Just kind of understand as you're progressing through the generations, it is getting significantly faster. So a 4th gen or version 4.0 is going to move significantly faster than a PCIe version 1. So you're moving up in speed and decreasing in power consumption. Questions so far with this? Standard color for a PCIe slot in a motherboard. Typically, what color is it? So you can quickly identify it. So we know the regular PCI is what color? Jordan got it. So PCIe is blue. What color is the, there we go, Janina. PCI is white or cream color. What color is the AGP? Brown. I saw you mouth it, Mark. Good job, TJ. So not always the case. Again, as we stated, some boards are designed with aesthetics in mind, so they're meant to look pretty. So they will do like all in black, or they'll do carbon fiber or like neon colors and different stuff like that, just, you know, to go for a particular look. But standard boards that you would see like in an enterprise setting aren't like that. You will typically have the color coding involved, as well as with the wirings. The wirings will tell you if the voltage that's being used with those wires. No, you don't have to memorize that, but it is a good idea to be able to read a wiring schematic. So you can be able to identify these things. But again, if you're going for aesthetics, they may have the casings around the wires all the same color, just so you get that uniform look inside the computers. All right, any questions so far? All right. Now, look here. Get my annotator. So right here, you have a by ones, so you can see they're rather short. And then over here, significantly bigger, you got the by 4. By 8 would probably come to about here. And then you got the by 16, which is significantly longer. So size on the actual motherboard is going to determine what type of PCI slot you would use. And for those of you doing the labs and test out, do we try to fit a PCI by 1 card into a PCI by 16, PCIe by 16? No. And we do not. So we pay attention to the actual connectors that we were using, make sure we're using the correct slots. And then here we have a cream colored PCI slot, which is that legacy technology that is kind of working its way out, though they will oftentimes put in at least one on a ATX board just in case. Questions so far? I got one. Go to the cards here. Romario, what are the different sizes of PCIEs? How many and what are they?
Ooh, you just said.
Romario. You're on mute now. I can't hear you.
That's actually eluding me right now.
Phone a friend.
Jimmy, you got this one?
Not sure, but I think it's 3. And I think it's by 1, by 4, and by 16.
Close.
No,
What you got, Janina?
there are 4 by 1, by 4, by 8, and by 16.
Perfect. Thank you. Excellent.
Jimmy,
So-
there were 3 in the example. That's why you probably
went
were
with
thinking
3.
3. And Kelly, I would like to interject for just 1 second.
Oh,
So you actually can fit a PCIe by 1
Oh, you can?
into a PCIe by 16.
okay. My mistake.
However, it will work just fine, but you are wasting that slot because the larger the slot, the more throughput it has. And so it's larger because it needs more throughput. And so the things that you will put into it, like a graphics card, it needs more throughput to work effectively. But if you put a PCIe by 1 into that slot, it isn't getting extra throughput. It'll still get the same amount as if you put it in a PCI by 1. You're just, you're using up a slot that could be used for something beefier.
Oh,
So there's
thank
not
you.
a real,
I stand corrected.
there's no real benefit other than placement. So
Okay. I thought the slots would have interfered. I stand corrected. Thank you, Avery.
yeah, if you go back to the previous page, Kelly, or it's either the previous one or the one before that. you'll notice in the PCI by 1, next to that PCI by 16, that little notch close to the front of it is in the same spot.
Okay.
So it'll still fit in the notch. You're just not using the rest of the by 16.
Okay. Well, thank you.
Yeah.
Like I said in the beginning, not everybody knows everything about IT. There is going to be cases where you may not know it, but your teammate does. Case in point. All right. Any other questions? All right. Next, we'll talk about chipsets with regards to the motherboards. They have a chipset which are integrated into the motherboards and circuits themselves, and they support the CPU communicating with it in order to help talk to other peripherals as well on the boards. The most common that you will have on the motherboard themselves is the North Bridge and the South Bridge. How do we identify the North Bridge? Who can tell that? Let me pull one out here. So TK, how do we identify the North Bridge on a motherboard? You there, TK? All right, Jordan, we'll go with you. We haven't heard from you today.
Isn't it like the second highest? I don't know, like I think y'all said something about geographically it's the second highest on the motherboard.
Getting close, getting close. Romario?
Isn't it the North Bridge closer to the CPU?
Very good. It is close to the CPU, but how would we identify it?
What are those prongs that are kind of sticking up?
What are they used for? What do we use those prongs for?
It's at the tip of my tongue too. Oh my goodness.
Alan's about to jump out of his seat.
You see me like phone a friend. Doesn't it help? It cools off the CPU. It helps cool it off.
So what's it called?
The metal tower, the North Bridge.
North Bridge. It is the closest chipset to the CPU, and it's identified by the heat sink sitting on top of which of those metal prongs.
Heat sink.
So it is siphoning the heat away from the chip to help it cool down. So, but very good, very good. So the North Bridge, as in real estate with housing and stuff like that, what's the most important thing with the housing market? When you talk to a realtor, what is the number one thing that they tell you about a house? What's the most important determining factor of how much a house is going to cost?
Location.
Location.
Location, 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 location. So North Bridge, that is close to the CPU because even in, the communication on this board, an inch can make a lifetime worth of difference with the speed of the communication that's happening between these components and the CPU. So it needs to be physically close to the CPU to have the most impact for the components that are hooked up to it, and anything hooked up to the North Bridge needs really fast communication with the CPU. So this is going to be your RAM. This is going to be your graphics cards, things of that nature. All of that needs really quick response time. So it's going to be connected to the North Bridge itself. Now, over time with motherboards and things like that, in order to create greater speed and lower latency, we integrate these things into the circuitry. It used to be that you had to put a NIC card in every single computer and then tell the computer how to communicate with it in order to be able to hook it up to an old telephone line and spend 12 hours downloading a single picture. Thankfully, technology keeps increasing, and overwhelmingly, NIC cards are now incorporated and built into the circuitry of the boards to allow for significantly faster communication. And in order to enable that, we continue to move things closer and closer and closer to the CPU. Modern motherboards and CPUs now, they're incorporating the North Bridge into the CPU chipset now to allow for even faster communication. So they're starting to incorporate that stuff as they're able to shrink down, you know, the components and, you know, parts and stuff like that. They're able to incorporate more and more and more into that central processing unit. And that allows for greater speed, greater communication. Now, not everything needs to talk to the computer that fast. So enter South Bridge. So this would be your mechanical hard drives, external peripherals that would come in through your USB, BIOS, your keyboard, your mouse, all that stuff is not going to be pushing so much data at a high speed, needing that reaction rate. So we use the South Bridge for that communication medium. So those are your two main chips that you need to be concerned about on the motherboard itself. Your North Bridge for all your high speed, fast response communications need to go through there. South Bridge for all the slower stuff that doesn't need as high speed communication. We're talking about milliseconds in difference, but that can compound over time. Yes, Jimmy.
What is that last? It handles all I/O functions. What is that?
I/O, input, output, I/O.
Okay.
So all of your peripherals that you would hook up, mice, speakers, headphones, microphones, keyboards, cameras, all that fun stuff go through, they're considered I/O, they're inputs or outputs. And those would be external connections to the computer, and all that would funnel through the South Bridge. Any other questions so far? And obviously, the more we push through these things, the more heat they create, and we need to disperse that heat, hence the heat sinks. And that allows for very, very quick identification of the North Bridge, because it will be the largest heat sink outside of the CPU, and it's generally geographically close to that CPU. We talked about yesterday the two major chipset manufacturers, Intel and AMD. How do we know if it's an AMD chip? I just flipped it over and looked at it. How do we know if it's AMD? Go ahead, Luis.
Has pins, and Intel is very smooth in the back.
There you go. There you go. AMD has pins. Very good.
Hey, Kelly.
Yo.
I'm not sure if we cover this throughout this lesson, but a lot of newer motherboards actually incorporate the North Bridge into the actual CPU. So
I was just talking about that.
Were you? Oh, sorry.
Yeah.
I'm doing 5 things. I was just making sure that, if somebody saw a newer motherboard, they didn't just get real confused. All right, glad you covered it.
I appreciate it. Thanks for keeping me on point. Interestingly, even inside the CPU, if you took the CPU apart, you would actually see little mini heat sinks in there too. So it's used throughout for heat dispersion. So they are there. Here is kind of a breakdown of the architecture to kind of give you an idea what is connected to what. So you have the CPU up here. And then immediately connected to it is the North Bridge, or the memory controller hub, so the way they would identify it. And then you see you have the RAM slots over here attached to it, and then high-speed graphics, or PCIe or AGP slots would be connected to the North Bridge. And then you have the internal bus, which would go to the south bridge bus, or the IO controller hub, or input output. And that would be where you would have the older PCI slots, the onboard graphics controller that's built into the motherboard, and then your exterior peripherals. You would also use, your IDE, which is like your old floppy drives. Those type of connectors would go through the south bridge, your SATA hard drives, USBs, your Ethernet connections, all that stuff. CMOS would come through the south bridge, through the internal bus, into the north bridge, and then the north bridge is the main connection to the CPU. Also connected offset, you have the clock generator. Really old technology. Can anybody tell me what we use to generate the clock speed inside a computer?
CMOS.
I like where you're going. Unfortunately, nope, that one is not it. The CMOS is connected down here through the south bridge. So CMOS is down here. So what do we use to generate, to let the computer, like the internal clock of the computer to determine its speed? What do we use? It's an old technology. Yes, Humberto, real quick.
This is a piezoelectric quartz crystal.
It is a piece of quartz crystal. Very good. Thank you. Where else do we see quartz being used? There we go. Thank you, Renzi. Watches. So internally in a computer, they will actually have a chunk of quartz in there that is used to generate the clock speed inside the computer. So everybody's working off of the same times. You have anything to add to that, Ellen, or did you have a question?
Kind of like it's not necessarily off topic, but it's about computer batteries and computer times and dates. Do you remember Y2K?
Oh yeah, I remember Y2K.
So was it the CMOS battery or the quartz crystal?
It was the original programming of the BIOS. They only left 2 numerical slots for date. Because the 19 was automatic, so they only left the last 2 available. So the problem was it would create a logical error once it rolled over from 99 to 00. It would create a logical error that things have been, it's 100 years off of where it should be. So that would create an internal logic error in a lot of systems because the BIOS wouldn't be able to recognize that. That's where that whole thing was kind of stemming from. Yes, Humberto.
Yes, according to this architecture, we can say that every computer will have a PCIe for the north bridge,
yes,
and a PCI, the old one, for the south bridge.
Yes, PCI, the older technology, goes through the south bridge because it does not have as fast of a bus speed, nor does it need that rapid a communication. PCIe does need that rapid communication because that's where you put your graphics cards and all that kind of stuff. So it needs to have that direct link to the north bridge to communicate to the CPU. So back to the quartz crystal. The reason they use quartz, same reason they use them in watches and stuff like that. It was discovered a long time ago. If you put an electric current through a quartz crystal, it will vibrate at a consistent and predictable rate. They call it the piezoelectric effect. That is why they use quartz inside computers, because it allows all the components in there to work off of the same clock. So not everybody's working on their own piece, and they won't be able to communicate with each other if they're doing that. Avery will get into that a little bit later this afternoon. The way the pulses are sent through, it's almost like music. You got, eighth notes, quarter notes, half notes, and they find ways to operate within those pulses of the clock to increase their speed and efficiency in communication. So, any questions so far with regards to this? All right, so just try to keep it in your mind, makes it a little bit easier. All your inputs and outputs and stuff that you would connect to the computer, they would communicate slower, south bridge, slow, south. All the fast stuff that needs to communicate, RAM, graphics cards, all that stuff, north bridge. North bridge has to be closer so that there is less distance between that the two components for communication. All right. 3, this talks about it here. As we move along, a lot more things are incorporated closer and closer and closer to that CPU, because the closer we can get it, the faster that communication can take place. So these modern CPUs are starting to absorb the North Bridge internally into the central processing unit to allow for greater communication, because you will have multiple cores inside those CPUs. And we want to increase that communication speed as much as possible, especially as we're going along. That's kind of how we're getting around Moore's law at the moment, because we were approaching a roadblock with it. South Bridge would be typically the only one visible on the most modern motherboards. And they now call it the platform controller hub. They're not going to ask you that, but that's just in case you hear that term. It will point you to the South Bridge. All right, clock check. Oh, we've already covered this. So the quartz crystal, as we just discussed, when electric current is put through it, it vibrates at that consistent rate. 1 megahertz equals 1 million cycles per second. And they use that to set the internal speed for the computer itself. Questions so far on the clock generator? BIOS. We talked about yesterday. Basic input, output services. Serves 3 purposes. It enables the CPU to communicate and manage all devices connected to it, and will essentially establish basic communication with those devices immediately upon hooking up. Plug and play is what they call it, although it is sometimes called plug and pray. You will have generic communication with them, and then as you get online and stuff like that, they will go out and get updated drivers so that they can actually have full functionality. Startup, the BIOS performs hardware initialization. It kind of checks everything, makes sure everything's where it's supposed to be. It goes through that power on self-test or post to make sure you don't have anything that's got a faulty connection, anything broken, like if you can't communicate with a hard drive or it can't find a RAM module, something along those lines. It'll give you those beeps if it's unable to find it. And then you will have a hierarchical setup to tell it where to go looking for operating systems. So you may say the operating system is in the hard drive. So when it goes and looks, it says, okay, I need to check the hard drive. Well, sometimes you can run operating systems off of a USB flash drive. So you can put a USB flash drive over the hard drive. So the USB flash drive would be number 1, hard drive would be number 2. Why would you do this? Well, I operate off of a Mac. Sometimes I may want to operate in Linux. So instead of utilizing a program like Boot Camp or something like that, I can put Linux, because it's a smaller platform, onto a USB and plug that into my computer. And whenever it's plugged in, when I turn my computer on, it looks for the USB first. If it's there, it boots up Linux. If I boot my computer up and there is no USB plugged into the back of the computer, it will say, nope, nothing there. What's my number 2 spot? Okay, I need to go look at the hard drive now. So then it will go look at the hard drive for that operating system. And you can set it up however you want, because you can have the optical drives like the CD-ROMs. You can have it go looking there. You could have it going looking over the internet to your servers at your office. But the BIOS is where you would establish where they go looking for the operating system and in what order. Any questions with regards to that? And that's what they mean by boot order. So word of caution here, in an enterprise setting, in a business setting, you do not want to have it set to where it will want to boot from a USB drive. You want that function turned off. Can anybody tell me why? Anybody has a guess as to why you would turn off the USB in boot order? Go ahead, Mark.
Is it because it won't go any further until it finds, well, no, that's not the answer. I was gonna say it wouldn't process any further until it finds that particular piece of the puzzle.
Well, all we're saying is like, no matter where it is on that puzzle, not to boot from a USB.
Okay, the right information may not be on that particular flash drive when it's plugged in.
Well, I mean, because we're setting it up in order. So it's actually a security question. Because you can put all sorts of nasty stuff on a USB hard drive and you plug it in and you boot from it, it floods that computer with all, all that nasty code that you wanted to build and will give you backdoors into their systems. So that is why you would not want to have that particular thing turned on. You actually would set it up so you do not auto run from USBs ever.
Got another quick question.
Okay.
Reading this information here under System BIOS, it says it's stored in a flash ROM.
Yes.
ROM chips that can be overwritten.
Well, it is a new type of ROM because you can what they call flash the BIOS.
Okay, yeah.
Because it allows for more longevity for those BIOS programs, because you're going to be updating them with security updates and stuff like that. Before, it was like we never updated it at all. Problem came in is if somebody figured out an exploit to get in the back door through your BIOS, you couldn't fix it. Now we can fix it. So you would do something called flash the BIOS. Yes, I know it's supposed to be read only, but they've actually adjusted it to where it can actually be, written to. It is, I think I mentioned it back on Wednesday, it's one of the most stressful things you can do as an IT tech when you're flashing the BIOS of a drive, because if anything happens, if there's a disruption in signal, you lose power, anything along those lines, you now own a very expensive paperweight. It is a brick. So you'll see them hooking them up to like 2 different uninterruptible power supplies, making sure everything is in line, before they will even touch flashing the BIOS, just because of any interruption will ruin it. And if you're talking about expensive servers and things like that, it's a lot of money. And you also don't want to lose all that information that's on those servers. Yes, you also want to do backups before you do any of that stuff, but but you really don't want to, trash a $10,000 piece of equipment either. So that's why, that is there. It's so you can kind of fix exploits and also upgrade the systems to have more functionality in time. And then it requires that little watch battery to keep all settings in there. And if that battery, fails, then your all the settings you make, like where to go look for operating systems, the time and date, the plugins and drivers and stuff for all your peripherals, all that gets lost, and you have to redo all that stuff. And so if you ever have problems with the BIOS, one of the key things to look for, if your Cmos battery has died, is to, every time you turn on your computer, it's asking you to update the date and time. That means every time you turn off your computer, it's erasing the memory and you're losing it. So that tells you right there that the Cmos battery is dead and needs to be replaced. Also, you can use that function to your advantage, because in an enterprise setting, you will put a password on the BIOS so that people don't go in and mess around with the BIOS in general, because you can do a lot of damage intentionally or unintentionally when playing around in the BIOS if you don't know what you're doing, or if you really know what you're doing. So you will put a password on the BIOS. Sometimes this is neglected, and an employee will go in and set a password on the BIOS themselves, which would lock out the employer. The way to get around that is there's 2 ways to do it. There's a jumper stick that you will move, which we'll show you later, or you remove the Cmos battery and it resets all the settings, including the password. So what you'll see in enterprise settings, for security reasons, they will lock the case. They'll put an actual physical lock on that case So you can't get in to remove the CMOS battery to reset settings. So, but we will get into that a little bit more when we get into security. All right, so here is the CMOS battery right here, just to kind of give you a quick look at what it looks like right here. So there is your CMOS, and then the firmware chip where everything's stored, typically right next to it. Here is an IDE connector that you use for hard drives, something like that. Trying to see, I think right here is the jumper post. It's a little stick that you kind of pick out, and then you put it down, push it down into another spot, and it automatically resets the BIOS as well. But you can do it just as easily by removing the battery. Questions so far? Right. So modern update to the BIOS, the UEFI, Unified Extensible Firmware Interface. This is the newest version of BIOS. It is far more robust, has a lot more features, it's more secure. Quick and easy way to tell whether or not you're using BIOS or UEFI. If you're able to use your mouse, it's UEFI. If you have to use the arrow keys to maneuver around, likely it's old school BIOS. You will have labs in test outs that will get into the BIOS, give you, kind of a scavenger hunt to go in and look for stuff in the BIOS, as well as going in and updating things in the BIOS. So you'll get a chance to kind of play around with that. I believe those labs are set for tonight, and we may have another one coming up in a little bit, but you obviously have until Sunday to complete the labs if you so choose. The original BIOS couldn't support file systems larger than 2 terabytes. So UEFI is able to exceed that, thankfully. BIOS only supported 32-bit architecture, where UEFI supports 32 and 64. And it is a much nicer looking configuration. So this is what UEFI looks like when you are in it. So it is much more functional, nicer to look at, gives you a nice dashboard where you can monitor all sorts of stuff in there. If you wanted to overclock your CPU, you could do that here in the BIOS. You could monitor the temperature of the components in there. You can monitor your fan speeds. All that fun stuff could be monitored in the BIOS or in the UEFI at this time. Does anybody in here or anybody want to explain what overclocking is? If I say I overclocked my CPU, does anybody know what that is off the top of their head? Yes, Humberto.
Yes, overclocking is when you speed up the frequency of your clock. So the system will run faster.
Yes. So you're essentially running that, you're telling that system, or you're telling that chip to run faster than it's designed to run. So Janina has had a pretty good correlation with it. Can you do it? Is it kind of like with a car? Yeah. You can kind of do that as well with a car.
She's stepping on our toes, Kelly.
You what?
She's stepping on our toes, man.
Stepping on our toes.
Trying to work on that, Diaz. Shh.
So back in the day, I mean, they are installing functions, unfortunately, now into the UEFI BIOS to kind of prevent people from overclocking their CPUs, to getting that extra juice out of them. Unfortunately, if that's something you do understand, there is going to be a byproduct of that. You're going to shorten the life of your CPU, and there's going to be a lot more heat production. So you need to upgrade your cooling components to something a little more robust if you're going to do something like overclocking. I think back in the early 2000s, AMD thought they would be smart because typically you're sending out a couple different versions of a chip. You'll have like the high-end gaming version, you'll have the standard version, and you'll have the economy version. But of course, in a manufacturing standpoint, you're producing 3 different chips. So it can be expensive. So AMD, the engineers, they were like, hey, I got a great idea. What we'll do is we'll just produce the same chip for all three, but we'll have the chip tell the CPU only to operate at certain speeds. So if you pay the extra money, it will unlock the capability to operate at higher speeds, but we only have to make one. So it's less expensive for manufacturing. Wonderful thought, right? Way to make things a little more streamlined. Well, unfortunately, people in the computing world are real quick to figure stuff like this out. So it wasn't long before it spread around real quick. Hey, just buy the economy chip and then you overclock it in your UEFI, and you get all the benefits of that nice souped up CPU, but at half the cost. So they didn't really sell many of the higher end chips once that was figured out. So the next time they came out with the next generation, they started making 3 versions again, and they weren't going to try that again because they lost a ton of money. So all those functions and stuff would be done here as well. All right, connectors. Various different ways you will hook up to your computer. Some of you are already starting to get familiar with these by operating in test outs. Right here, you have your PS1 or 20+4 connector, which is your main power supply connection. So that's going to be one of your biggest connectors sitting on the motherboard. Over here, you have some fan connectors. So you have like little 2-pin, 3-pin, 4-pin. And then you have the IDE right here, which is for like floppy drives, like old school floppy drives and hard drives and things of that nature. These are the older connections, would be the IDE connectors right here. You have the front panel connectors right here. These would be the little lights that you would see turn on the front of your computer when you press the button. So it would be lights, it would be the speakers that are connected to the case. The button that you push to turn your computer on has to be hooked up. It has to be connected. So these front panel connectors right here would be how you would enable the case to talk to the motherboard. And to know how those goes, how those are supposed to be hooked up to the motherboard, big pro tip, look at the manufacturer's recommendations and the schematics in the product information. If you don't know where something goes, look at the details and the schematics. They will tell you where things are supposed to be hooked up. So up here, you see right here, we have a 4-pin fan connector. So typically you would have your, was it your negative post? And then you would have the 2, one would say for turning the fan off and on. And then you would have an extra pin that would tell the fan to do speed, like how fast the fan was going to turn on. So in a 4-pin fan connector, that's what you would see. Now, say I have a 4-pin fan connector, but my motherboard only has 3 pins. What do I do? What's the venture a guess on that one? Go ahead, Humberto.
Yeah, you can connect on that slot, but you lose the speed control.
Very good. Very good. So if you have 3 pins and a 4-pin connector, you go ahead and just plug it in. Hint, you will probably hear that question again. So if you only have 3 pins and a 4-pin connector, you go ahead and plug it in, because the only thing you are going to lose is the speed of the fan, but you'll still be able to turn it off and on to cool the CPU or the computer. All right, so your front panel connectors right here, this is where you will see them. And again, refer to the schematics or the documentation to know how it will lay out. The other thing is, if you look closely at a motherboard, I think you can see it. So So here's your front panel connectors. You see all this writing right here and all over here. You see all this writing that's on the boards. In the wild, when you're looking at a motherboard, they have in print next to each plug what it is. It'll tell you. So next to the Cmos battery, it'll say Cmos. Next to your Sata connectors, it'll say Sata on the motherboard in small print. So it's there for you to see. But you can also use the documentation. I will tell you, for the tests, they make it blurry enough where you can't read it. So don't rely on that for the test, because they intentionally blur it so that you're not able to read that stuff during the test. But in the wild, when you're actually working on computers and stuff, you can physically read it if you need it. So SATA connectors right here, a little tough to see, but they are an L-shaped connector, and they are used for hard drives and optical drives and things of that nature. So right here, SATA. And then I think we got over all of these. You have the Molex connectors right here. All right. Do we have any questions so far with these? All right, moving along. External connections. We went over this pretty well yesterday. You do have your USB 2s. How do we know the difference between a USB 2 and a USB 3 visually? If we're looking at it, how do we know the difference?
Color.
Color. So USB 2 right here, black. USB 3, blue, or yeah, blue, light blue. So that is a quick reference, because if you have a USB 2 item, you don't want to waste a USB 3 slot by utilizing it, because it's not going to make it communicate any faster. You're just wasting a slot at that point. So make sure to check your connectors on the back, and be sure you're using the right connections for the right USB ports, because though it will fit, it will talk, you could be wasting a high-speed connection on a slower device. Like, you do not want to plug a keyboard into a USB 3 port. It doesn't need that fast of a connection. You know, you may want to use that for hard drive or something like that, like a solid state hard drive that's going to need a much faster connection. So be sure to pay attention to that. Also, we have here, which is the display port, which you see is flat. Need my marker. So it's like flat on one side, and then the other side is angled like this. It's a little tough to see in the graphic, but you can kind of see it right here. It's flat, and then it has the angle over here. If you do a quick glance, you may confuse it for the HDMI, but it is not an HDMI connector. HDMI connector has angled points on both sides. Then we have the DVI connector up here, DVI, which was the replacement for the DB15, which is the old analog connector for monitors. We will show you that a little bit later when we get into cables and connectors. They have a whole technical session just on those. DVI was a bridging technology between analog and digital. So it's identifiable. It's usually a white connector. It has a series of pins, as you can see here, and then it also has a metal post off to the side over here. So that's how you would identify it looking at it face on. Then we have our RJ45 or LAN connection, local area network. Go to the internet. We have our fiber optic audio that Mark pointed out for us yesterday, and then our other audio visual connectors as well, right here. Any questions with regards to connectors? Just two more I got to go over real quick. There's the FireWire, which is right here. And you kind of know the FireWire. It looks like an arrow, goes like this. And it kind of comes in that I draw horribly, I write even worse. But so it kind of looks like that. That is how you would identify a fire wire. Also, over here, these little red connectors, they're also L-shaped connectors. They are SATA connectors, but SATA is only internal. These are identified as eSATA. Any ideas what the E stands for?
External.
External. Definitely want to remember that. If you do not see the E, it is not external. So eSATA, external SATA. Typically used for hard drives and things like that. Same with FireWire, that is also a hard drive connection typically. Any questions so far?
Yeah, I don't see the RJ12 there.
RJ12?
Yeah.
Newer, you mean RJ11?
Yeah, like in the lab, there was like an RJ12 and they had the RJ45. So I was like wondering where it was.
Typically on the modern ones, you won't see it. I mean, there are, you could get a NIC that has it, but on this particular one, it does not have it.
And Kelly, did you mention, because I don't know if you did, if so, I didn't hear, what type of display input is not there? Did you mention that, Kelly?
What, the DB15?
No, yeah. But hey man, I was throwing it to the class. I didn't know. Did you mention it?
Yes, it did.
Okay, well then I feel like Avery now.
Sorry.
I'm stepping on your toes, man.
That's embarrassing, Marvin.
I make one mistake in a presentation, and then it's like every 5 minutes. Hey man, did you talk about this?
No, man, no.
Don't forget to talk about USB.
Right. Like something very, yeah, that's awful.
So yeah, DB15, we'll get into that in the cables and connectors section as well. And DisplayPort is a merging of two technologies. No, that's Thunderbolt. Excuse me. Never mind. Moving on.
We threw you off then. See that?
Yeah, you did, man. I'm all messed up now.
Yeah.
All right. So kind of, you might remember this graphic from yesterday. It's a little more detailed. So we have our PCIs up here. Cmos battery. It's a little watch battery. Our external connectors. You'll typically see a USB connector around there as well. Here's the CPU socket. Based on looking at that socket, what brand of CPU do I need to buy?
Intel?
Two people talked at once. I didn't hear it.
Go ahead, Luis. You got
Intel.
It's got a bunch of little holes in it. Got the whole thing. So do we think Intel? Let's take a vote. Thumbs up if you think it's Intel.
Is there a way for you to like expand the picture?
Unfortunately not with Nearpod.
Gotcha.
But I'm telling you, there's a bunch of tiny little holes throughout that picture.
AMD, because it has the AMD processor has the pins.
Has the pins.
Yeah, I think AMD too.
There you go. So there's a bunch of little tiny holes here that would.
It was smooth on the back.
Yeah, Intel's smooth on the back, so it would not be able to communicate with this board at all. So if it was an Intel chip, you'd see a bunch of pins sticking up from the board to touch the Intel chip. So next to the CPU, there is a little close to the CPU geographically, you'll see like a little 2 to 4 pin connector that you would hook up your CPU fan. It has its own connection. Here we can see that 20 pin connector for the power. Up here we got our IDEs for floppy disks or hard drives, older ones. We have this big heat sink right here, which we know that would be our north bridge. We had our PCIEs right here to connect to our north bridge, and our south bridge is all the way over here. And then obviously our AGP right here. Trying to think. These battery looking things, what are these? It's like little batteries welded down to the board. What are those? Yes, Jimmy.
I was gonna ask, in a modern motherboard, so would the PCI slots just be replaced with PCIEs, since I don't see those on here?
Typically, you may see one PCI slot. This is an older motherboard, obviously, but you may see like one PCI slot just in case for legacy stuff. But for the most part, they're going to be putting more PCIe slots on the board. So yeah, these would be your PCI. Oh, my mistake. This is the memory slots, the DIMM slots for your RAM modules. So see a lot of people in chat, these little batteries that are sticking up look like little AA batteries that are welded face down onto the board. Those are the capacitors. That is what will store electricity even after it has been turned off or plugged in, which is why we hold that button down to disperse the charge. Now, inside your power supply is a whole bunch of capacitors like this. Not to be confused with the watch battery that's over here, the flat round battery. Yes, Humberto.
Yes, I am wondering, is it there the possibility to have a PCIe in the south bridge, or it never happens?
No, because you need a much faster connection. You'll have, if it's connected to the south bridge, it's going to be a PCI. They will not connect an express to the south bridge because there isn't a fast enough connection for it.
Okay.
So if it's connected to the south bridge, it is a PCI, older technology. Any other questions about the geography of a motherboard? We're all experts.
And I want to jump back on that, Kelly. Humberto, if you happen to see that, that's an anomaly. That's the exception. That's not the rule. Because I know people get weird with certain motherboards, and I hate to say that it never lived out there, Kelly. I think even with the older ones, maybe if it just happened to be there, super old, it shouldn't be there, and you're not getting the best performance while it's being there. And and newer ones would never put it there because that's not where it should be. That's not where it should live. Just FYI, because I know people, you probably find
there's an oddball. Okay. So in general, when we're asking questions, we're not trying to trick you. Don't look for the exception that disproves the rule.
There you go.
So we're looking for the general rule, not the exceptions. Of you could probably find exceptions to near anything we say here because people sometimes just build things to see if they work. So you might be able to find it, or they think like, oh, if I reconfigure it a different way, I might get better performance. So there are cases where you'll see exceptions to the rule, but don't look for the exception to disprove it. Because we would have people who, this is the threat for people who have an IT background and are heavily into computers before they come into this course, because they're like, no, I've seen that before. It's the exception, not the rule. And so that's where people who are coming in fresh with no IT knowledge tend to have an advantage because they don't have all these exceptions built in their mind where they can think of a way where this doesn't work. And so they will end up getting the questions wrong because of it. So, all right. So since we are all now experts on motherboard geography, we're going to break up into small groups. On your Nearpod, you should have this one brought up. Avery, if you could please put together groups of 3 or 4. And we're going to map out all the ports on a motherboard. Please try to refrain from using Google or any of that stuff. Again, I would rather you get it wrong than jump out and go quick, easily to find the answer. Here
You
to
said
try to
3 or
test
4?
your memory. What's up, Avery?
You said 3 or 4?
Yeah, 3 to 4 to a team, and then we will come back and have a designated person who will share out. Your room number will be your team number. All right. Any questions before we start heading into rooms?
All right, you ready for him?
Yeah, we're going to take about 10 minutes with your team. Remember to take yourselves off mute so you can all talk. If you are able, turn on your camera so everybody can see who they're talking to. And be ready to go. We'll come back here at 2 afternoon and we'll go over the answers real quick. Dominic, are you able to join your room? Hello?
I think there he goes. Or he's turning off his camera.
Bottom right hand corner, Dominic, just hit that join breakout room. And TK, I know you were handling some business. Are you with us or are you still away?
She said she was an appointment. Here we go. All right, our next phase of motherboards that we want to discuss is basic, motherboard maintenance on the average. Now, you're not necessarily going to be seeking out computers to do this. These typical maintenance things you will do are when computers would come in. It'd be like an attrition level maintenance. When you're already opening up a case, you would go ahead and perform these duties on top of what you were in there to do, just to kind of keep the machines operating in a clean and steady manner. Roughly about every 2 years, you would hopefully keep logs about this on various computers that you have as to how often this is done. You would clean your expansion cards and motherboard, removing the dust from the interior. This can be done with compressed air, which is one of the more common ways to do it. The other way to do it would be a vacuum cleaner. They do have PC specific vacuum cleaners. Can anybody tell me possibly why that would be? There are 2 main reasons. Can anybody think of a reason why we would have a specific vacuum cleaner type of vacuum that we would use for computers? Go ahead, Alan.
Would it be like it runs?
I think you froze on me. You still there?
Like the electromagnetic. I'm sorry. I'm trying to think and talk at the same time.
No problem. You're knocking on the right door. So
Like, is it like with the reason why you would kind of? I'm sorry. Give me 1 second. I think Fidel can go if he has the right answer though.
he's right there too. What you got, Fidel? The
I assume because of static electricity, something like that.
Yes, absolutely. Static electricity is definitely the main reason. That is why there are vacuums that are specifically built to vacuum out of computers. The other one is not so readily apparent, and that would be the power of the suction. You can damage components by the power of the vacuum as well. So it's going to be a lighter suction. Now, this, if you have PCs at houses, or if you're servicing PCs at houses, cleaning out the PC is more important because you tend to have a lot more dust and debris, depending, especially if they are keeping the tower on the floor. Another big thing is pets. I mentioned this earlier. Cats are the biggest offenders in this particular case because they like nice warm places. So they will climb in behind a PC and kind of hang out there just because it's nice and warm. What happens though is they tend to shed a lot, and that air will get sucked into the computer and never exit the computer. There have been quite a few computers that I have opened up, and it is just jam-packed with pet hair. I mean, like almost like a pillow. It is so compacted in there, you can't get anything out. And in that case, the computer can't breathe. So you would have to clean out all of that, as well as the intake vents on the front, to make sure that the computer can cool itself properly. And if you're having repeated heat issues, you want to check your vents and dust and debris interior as well. The other thing I want to be aware of is chip creep. So when you have metals or any material, in fact, but metals particularly, if you heat them up, they expand. If you cool them down, they contract. And so if you have two pieces connected to each other and they keep heating up and contracting, over time, they start to move. So these chips can start to move ever so slightly over time because of the repeated heating and cooling process that is going on inside the computer. And eventually you don't get a solid connection. So you might start to see intermittent issues because of, the connections aren't being made properly. So as you've opened it up already, you're already in there. You want to take your expansion cards, your RAM modules, and all that stuff, and just kind of snug them up a little bit just to make sure they're seating properly in the boards. Same thing for your cables. You kind of want to do just a quick check on your cables, make sure they're seated and snapped in properly, all of them, because over time, especially enterprise settings, where they're cleaning on a regular basis, especially if towers are kept on the floor or even on the desk, they get bumped, they get bounced. Cables, if they're dangling underneath desks, are going to get snagged by people's feet over time. And so they may loosen up. Same thing on the interior. If the computer is being bumped around a lot, some of these connections can become loose. So you just want to double check them, make sure everything is seated completely and properly. Now, periodically, you want to back up your BIOS based off of any recent updates that may have happened, just so you have something to rebuild from if you need to. And you want to make sure that your motherboard has the most recent version of the BIOS. And I got it right there. Flashing the BIOS is what it's called when you're updating the BIOS. What is the threat when updating your BIOS? Go ahead, Justin.
When you flashing your BIOS, if you have any type of electric short circuits or anything get unplugged or anything like that, it'll basically destroy the computer, essentially.
Yeah, turns it into an expensive paperweight, right? Here we go. Nice. Thank you, Justin. All right, now installing motherboards. This is something that replacing a motherboard is something you may or may not come across. I mean, if you're building your own PC, yes, you will do a motherboard install, but replacing a motherboard in a computer, Not really seen that often because with the fact you have to upgrade all the components inside it as well when you're upgrading the motherboard itself, oftentimes it is just less expensive to go ahead and buy another PC. Although we still need to understand the steps going involved in this. So if you are going to be replacing a motherboard on your computer, first step would be to research the type of motherboard you want and all the components that are going to go along with it. Justin, did you still have a question or you just still have your hand up? Gotcha. All right. So do your research, look into the motherboards. You know, if you're upgrading and you don't want to upgrade all your components, you want to see if it's still compatible with the CPU you have. The expansion, it has enough expansion slots for what you need and will still operate with all the peripherals that you still have in place. So you want to do your research just to be sure all of that stuff will still be good. So similar chipsets, all that fun stuff. Also, you know, cost benefit. All right, step 2, installing the motherboard. So you got to confirm through your research, obviously, and then once you receive it, verify that this is the one you want and need. You remove all the components from the old board. Obviously, there are a few steps prior to that. If you remember from yesterday, power down, hold 5 seconds, unplug, open the tray, and then you're going to remove the internal components, starting with the expansion cards and RAM, and then moving to other components as we go. Then you're going to install the IO metal plate, mount the board inside the tower. Now, when you're removing a motherboard out of a computer, it's not always just a straight lift. Sometimes you have to kind of do some finagling to kind of get it out of there. You should never, ever, ever bend the motherboard. It should be able to go in and out without you ever bending it. If you bend it, you run the risk of breaking it, damaging bus terminals, all that kind of stuff. Yes, Umberto.
What is it? The input-output metal plate?
The metal plate?
Yeah.
That is the back plate. So that when you install it, it has a, it's still flush.
Okay, okay.
So it's the back plate, I believe, with all the components that you plug in, like your monitor, USBs, all that fun stuff in the back. All right, so once you put the motherboard back in after you remove the old one, make sure you line up all your screw panels, and then you're going to screw down the motherboard gently using a cross pattern. You're never going to go like clockwise through all the screws. You're going to start at one, and then you're going to go to the one exactly opposite from it, and then you're going to move in an X pattern. That way you don't over tighten one side and the board is cockeyed, and then when you screw down the other side, you could bend or break the board. This allows for even pressure to be applied to it, and the most secure way of putting it in. You also don't want to over tighten it, like you should not be using a drill typically to crank down these screws. Probably best to just use a handheld screwdriver and do it to like finger tight, maybe just a little bit more. After you have the board installed, you go ahead and put your CPU in place, apply your thermal paste, put your cooling unit on top of that, be it a fan or liquid cooling or what have you. Then you would go to your RAM, components, cables, cards, and then after that's done, close it up, attach your monitors and all out, you know, exterior peripherals at that point. Any questions so far on that? Again, we'll have this presentation available for you guys so you can go back over it if you need to. All right. Next, after everything's installed, you turn it on. You are so happy that you got through post without the multiple beeps going off. You will be set into your BIOS. That will be the first place you go. And that's where you start configuring everything, to telling it where to look for the operating system, setting your date and time. You can, if you so choose, disable an abbreviated post and do a more extended check if you wish. Set your boot order. Ensure that all your hard drives can be seen, all your RAM can be seen. So the computer sees everything that is hooked up to it and it is configured. Once that is good, save your configuration, exit, and then observe that it goes through, like do a restart, observe it goes through post with no errors. And then if it starts up, you can install your operating system, be it Windows, Mac, Linux, whichever you choose, and boot into that with no errors. At that point, if you've gotten into your operating system, then you can now upgrade all of your drivers for all the peripherals you have attached, because remember, when you are initially installing it, you're just getting basic drivers, which will allow for very remedial communication to like printers and keyboards and mice and all that stuff. So if you have a lot of bells and whistles with it, you'll need to update the drivers so that the computer can actually fully utilize those things. You'll see often when you have a generic driver, if you have an HP 5370, the driver that will initially be used would be like HP 5000 series. And it may not have all the, you know, it may not have the WPS connections. It may not be able to do printing, dual-sided printing, all that kind of stuff. Yes, Mark.
Would you recommend changing the CMOS out at the same time changing out the motherboard?
Well, if you're putting in a new motherboard, I hope you're putting in a new Cmos battery. Cmos batteries are very cheap. They're like $1.50 a piece. A lot of techs will keep like a stack of them in their tool bag just for quick use. And if ever you're going in and doing maintenance on a computer, like if you got to do anything major to it, go ahead and just flip out that Cmos battery. It just saves you time later. So I like that you brought that up. That is something like if you're doing normal preventative maintenance, you might just go ahead and swap it out just to prevent the issue going forward. Because the CMOS battery is typically only meant to last maybe 1 or 2 years. All right. Any questions so far? If none of this has worked, you would go back into your BIOS, reconfigure, try again. Again, we have a lab in test out, walk you through the BIOS. You'll have kind of a scavenger hunt to go through and look for things in the BIOS. And there also will be a configuration one in the BIOS as well. All right. Here are some of the things that you can update in your BIOS once you get them all up and running. It has built-in diagnostics. If you have things that aren't running, if your computer's overheating, things like that, you can check here and it should actually tell you like at what temperatures you're operating at. Are fans even functioning? Because there may be a case where a fan is no longer functioning and it'll tell you if it's responding or not responding. BIOS can tell you that as well. Inside the configurations for BIOS, you should be able to set up your boot sequences, enable peripheral devices or internal devices, date and time, clock speed, bus speed will tell you that type of stuff. And then BIOS security, passwords and encryption, secure boot, and a version of LoJack for your computer. Now, the monitoring side, as we just said, temperature of the internal components, fan speeds, voltage, clock, intrusion detection. Has somebody opened the computer case? Sometimes they will have sensors for that. If the case has been opened, it will send an alert through the BIOS for that. Or if somebody has made changes to the BIOS, it may also notify you to that, and then we'll let you know as well the bus speed if you're having issues with that, if one of the pathways has become damaged or is having intermittent issues. Questions so far? The built-in diagnostics, again, the lab will allow you to play around with that just a little bit. And there also is a sandbox in test out as well. I encourage everybody to go in there and use a sandbox. It gives you like a whole office where you can go in and mess around with any computer. You can go all the way down to the BIOS, change settings, see what it does. Feel free to break any computer while you're in there, because breaking it will, kind of teach you what you should and should not do. And then if things get too bad, you can always just reset the sandbox and everything goes back to what it was at the very beginning. It'll even let you go into the networking part of it, go into the server rooms, mess around with that stuff. So it's a lot of interesting stuff in there and a lot of stuff that you can practice with and play with around in there. That is it's considered chapter 14 in test out. but you'll be using that more and more as you get further along, but there is room to play around with the BIOS in there. So, all right. This is what old school BIOS will look like. It looks quite different from the UEFI picture we showed you earlier, right? And this is very, very basic, monochromatic. The only way to move around is to use your arrow keys on your keyboard. That's how you move through menus and stuff like that. There is no mouse input at all. It is all keyboard input. That's it. That is BIOS. The one we looked at earlier that was nice, had that nice black background and all the fun graphics and stuff like that. That is a UEFI. Questions so far? All right, common pitfalls when installing motherboard. Biggest one is the ESD bracelet, because again, what amount of voltage does it take before a human feels something? How much volts does it take before a human would actually even feel it? There we go, Jimmy, 3K, 3,000 volts, roughly. It's 10,000 before you see it. So if you see a spark, that was 10,000 volts. How much does it take to damage a component in a computer? 100 volts. So it is a big threat and you'll never even know you did it. So always be sure to utilize an ESD bracelet, anti-static bags, ESD mats, or ESD gloves, something that will protect those components from electrostatic discharge. Never wear jewelry on your hands unless you're covering them with electrostatic gloves. Then it is okay, because your jewelry can actually inadvertently create a connection between 2 points on that board and cause a short. And as the capacitors may have stored charges in them, fry out those components at that point. So tie back long hair. Again, Marvin and I do not have this problem, but some people out there may. Be sure to keep it back out of your face and work here so it does not fall into the open computer.
I'm growing it back, man.
Growing it back?
Yeah.
I'm thinking about doing the ZZ Top beard. I'm not sure. It'll only take me about 10 years. Always hold the board by the edges. Avoid touching any soldering points because they can be sharp. They can cut you. And any connection points, because the oils on your skin will cause them to rust and degrade. So some other pitfalls people tend to not think about when they're in a rush. Do not use magnetized tools. We did speak about this yesterday because these magnets can damage components. Take extra care when you're damaging when you're tightening down the screws, that you do not go too hard when you're tightening them down. This is not a tire. It does not need to be held on going 80 miles down the road. You know, you are just getting it in there finger tight, maybe just a quarter turn after that. That's all you really need to hold that component in place. I mean, we're not playing football with the towers, none of that stuff. It just needs to be held, and it's going to be in a stationary place for the majority of its life. Next, be sure to count your screws when you remove them, and then when you're putting them back, to make sure that you don't have any that go AWOL. Because if they have, they could be rattling around inside that computer, they could be in a fan, and they can cause damage. So just make sure when you're pulling the screws out, you count them. When you're putting them back in, you count them again, just to make sure that you've hit every one that you need to hit. And then you never force a motherboard to fit into the IO slots. If it does not fit, check your IO plate, the metal plate, and make sure you have the right one in place, because they are made to fit those boards. One other thing that I would suggest, if you are ever opening up and going into any kind of electronic, be it a computer, be it a mobile device, a laptop, what have you, as you are unscrewing the screws, make yourself what's called a screw map. I actually have a mat with a bunch of indentations in it so that I can lay out the screws in the pattern to which I'm taking them out. And some people have a system to it, like they'll start at the top left corner and they'll unscrew everything in a clockwise fashion. You know, just whatever method you have to find one that works for you, but find a way to keep track of these screws as you're taking them out so that when you put them back, they go in the right place. Because in cases like mobile devices, they have different threading. So the thread count is a little different. Some may be longer than others, and some of the screws themselves may actually be magnetized. I know we say don't use a magnetized screwdriver, but that ends up being the case. Some of the screws themselves may end up being magnetized. So you just, if you lay out a pattern, some people will lay a piece of paper down and draw circles around each of the screws and then, you know, where they go in the device. So like if you have a computer, just draw a little bit of a square and then you put them in, like draw little circles on the paper where you pull the screws out and you lay the screws in the circles. That way, when you go back, you can put them back in. So, I mean, there's just quick and easy ways you can do it. Just a way to kind of give yourself a map to put things back together so that you don't, you know, put a short screw in a long hole and end up having to over tighten it just to get it to actually grab, or put in, you know, a long screw into a short one and, you know, you aren't able to get it tight enough, or cross thread it because you have a different thread pattern, which will strip out the screw and damage it very, you know, possibly ruining the component. From ATX to Micro ATX, say, what is it, like 8 screws, I think, for an ATX. But the Micro ATX is a little bit smaller, so like the 3 bottom screws may not be used, just the ones from like the mid tier and up. So I like that question. All right. Let's see, there's that. Next, common issues with motherboards that you got to pay attention to. That electrical burning smell. If you ever smell that or see blue smoke coming out from the back of your machine, unplug it right away. Snatch the plug out of the wall. Shut it down. Something has gone very wrong at this point, if you are seeing that. The computer does not boot and you hear beeps instead. So I hear these beeps. What do I do? Somebody tell me what I do. I don't even get a boot screen. I just get beeps. I get like 3 short beeps out of the computer when I'm booting it up. What do I do?
You will have to see the manual of the manufacturer to find out in which step of the boot process it stopped.
Oh, that's amazing. What if I lost the manual? I only got like a small closet. I got 500 motherboards, lost the manual.
Can you Google it?
Yeah, you can. You can go to the manufacturer's website and look at it. So I like where you're at, Humberto. Who said that? Who said Google it?
It was a lady.
Gina?
Rienzi.
Renzi or Gina?
Who was it?
I typed it.
Own it. I think it was Rienzi. Good job.
You got it right. Own it.
Renzi. I typed it, but Renzi said it.
Okay. Good job. Good job. Yeah, you would Google it, find out what it is. What are those beeps called? What is that? So we Google it. We know we got to Google, but what is it called? Justin's got it. Post. It is a post error. If you turn on your computer, before anything happens, you just get a series of beeps. That is a post error. And what does post stand for?
Power on.
Power
on self-test.
There you go. Power on self-test. Post. Very good. TJ got it too. Nice. Computer went rogue. Yeah, I would assume. All right. So you got your post error. So you would look it up on the manufacturer's website if you do not still have the documentation from your motherboard. So there is always a way to kind of try to figure it out. If you cannot log in using your BIOS password, I think we talked about this, you know, You had that disgruntled employee on the way out the door, made a bunch of funny changes to the BIOS and then set a password lock on it. How do we bypass that? How do we fix that?
You make the jumper.
Jumper cable or jumper pin. Very good. What's another way we can do it? Thank you, Mark. Removing the Cmos battery resets all settings, including the password for the BIOS. Not for the computer, just the BIOS. Very good. Buttons on the front panel are not working. Like I go to it, I install the motherboard, close up the case, push the button on the front, nothing happens. What do we think we do then?
Check the connectors.
Which ones?
The one from the front panel.
Very good. Front panel connectors, go in, make sure they are one connected, two in the right spot. Because it is very easy. I am not even kidding. It is very easy to put the front panel connectors in the wrong spot because these pins are tiny. And it's very easy to be over just one pin or the other. Yeah, also make sure the power supply is plugged in. There is a reason why IT asked that question first. Is it plugged in? And when people ask that question, also remind them cables have two ends. May not be that it may be plugged into the wall, but it may not be plugged into the back of the machine, or it may have just gotten bumped. It happens. So if you're actually working at a, an IT in on site and you go to sit down to help somebody's computer, they're having a problem with internet, one of the first things you do when you sit down is reach behind that tower and just check that RJ45 and make sure it's snapped in. Because it could come loose over time. Motherboard lights up, but won't power on. Thoughts? Power connector may not be in all the way. You're getting a little bit of juice, but not enough to actually get it going. You might have forgot to plug in the CPU power supply like we had seen earlier today. Remember, it's the 20 plus 4, and sometimes that 4 is disconnected and plugged in somewhere else to power the CPU. So there may be cases like that. And hardware not recognized by the BIOS. BIOS may need an update. So it might be that hardware came out after that iteration of BIOS was done. You flash the BIOS, get a new update installed, and you are able to recognize your hardware. Yes, Evan.
How often would you need to update the BIOS? Is there
Go ahead.
Is there like a certain time frame between each update, or does it vary?
It varies. It depends on the manufacturer. And it also depends on the vulnerabilities that are discovered. So there might be a version of it that's out there that's really stable. Nobody's really found a vulnerability, and you might go a year or two without having to upgrade that version of BIOS. Or there might be cases where the most recent update version that they put out had a lot of problems. And so there are several updates that come out afterwards just to fix those problems or vulnerabilities that were discovered. So it does vary by manufacturer and by versions. So any other questions? All right. Overheating problems typically lends to the fact that the computer is likely not able to breathe. That is one of the first ones. So you would make sure your vents are clear. Make sure the fans are, you've blown out the fans if you've gone in there. If you see a lot of dust when you open it up, go ahead and clean it out just to prevent any problems going forward. We talked about not enough power, incorrect components possibly. RAM not seated correctly would give, a post error. That'd be one of the first ones you check when you put a computer back together, because that's the easiest one to not get, because sometimes you don't get that hard click as you're pushing in those components, and then it's not recognized by the system. Case buttons installed incorrectly. We talked about that. Hardware compatibility and short circuit or broken capacitors on the board. All right. Any questions? We're almost to the end of the motherboard. But we have a game. So we go ahead and stop sharing for the moment.